So we want to wrap up this first problem. We want to wrap up the problem that we started in the last video. We found the original function and some good information, the first derivative, and where it's increasing, decreasing, and has extrema. We've also found the second one. So now that we know the concavity, I can pick out my inflection points. Wherever concavity changes, that is an inflection point. And then how do I get my y coordinates for those? Oh, that's right. We have to put that back into the original equation. Now, I know this is hard to fathom because it'd be very difficult to plug these x coordinates into the original equation. But it's not impossible. It really isn't. So when I did it, I actually got 36 for both of those inflection points. There is a bit of symmetry with this graph. I will not try and give you a problem this difficult without a calculator. And to be honest, if you had a calculator, you probably wouldn't need all this. I'll work very hard to make sure that the y coordinates either work better or you can give an estimate. But now we have enough information to put this together, and I'll show you what the graph looks like in just a few seconds. I want to show you an interesting trick. If you are trying to gain all of this information here, I can save you just a little bit of time. Watch this. If you wanted to do this the most efficient way, and you know that you're going to use the first and the second derivative, you can find out where it's increasing and decreasing, where there's maximums and minimums without ever making a sign chart for the first derivative. Here's how. If I look at 0, I realize that falls into this category right here. And on that section, it is plainly concave up. If I have a section of my graph that's concave up and it has an extrema, that extrema must be a minimum value. Likewise, this point at 3 right here falls into the middle category. If I have one section that is a concave down interval, the only possible extrema on something that's concave down will be a maximum. Likewise, same thing over here for 6. So you can quickly, just by checking the concavity, know whether you have something that is a min or a max. If one of your inflection points, one of your critical values from the first derivative does not fall in one of those intervals, that means it was an inflection point in the first place. So here is what this graph is basically going to look like. I started by plotting all the points that I know. I have 2 minimum values and x-intercepts. I have 2 inflection points. I have 1 maximum value. To get an idea of what this graph looks like, then I just draw the concavity. I know it's concave up pretty much from this point all the way to the left. I know it's concave down from the first inflection point to the second, and then I know it's concave up the last part. Do I know exactly the steepness or how high it goes up on the ends? No, but I've got the important portions here, the extrema and the inflection points. I've shown that I have enough information to make a very nice graph, and that's all that I'm really going to be looking for. We're going to get better at these by doing lots of them. The more that you practice, the better you get at remembering all the steps. And it is really just the same information that we've had from the beginning. All this information you can get back from pre-calculus, the first derivative test info, and the second derivative test info. That's going to help us put it all together. So keep practicing. I'll have maybe another video or two with some examples, but we'll do a lot of them in class. Thanks.